Here's a graph of an inequality, and we're supposed to figure out what the actual inequality is that produced this graph. Okay, so I'm talking about these things down here. One of those inequalities creates this graph that we're looking at. Let's figure out which one. And what I want to do is first talk about those dotted lines that you see. Those are going to be defining a lot about the inequality that we see below. And in this first one, see we've got a positive slope. I don't know a lot about it because I don't see any numbers on the graph, but I can say that the slope is going upwards. And I can also say there's a positive y-intercept. And let's look at the other one. Likewise, this is a positive slope. I can say that for sure. And I can also say there is a negative y-intercept. Now, I don't exactly know what those y-intercepts are, but I have a feeling the negative one is bigger than the positive one. Actually, we do know a little bit more. I can say, since the axes have equal scaling, the slope of this thing looks like it's about 1. So let's put that down as a maybe. M equals 1 on the slopes. I'm going to say the y-intercept, b, this is the positive one, looks like it might be 1, whereas the negative one, the negative y-intercept, looks like it might be negative 2. Okay, these are just guesses, mind you, but let's take those guesses and try to make some inequality functions. So the first equation, the first inequality might look like this. And I'm going to use y-intercept form. That dotted line right there is going to be y equals, let's say 1x, not m, just y equals x plus b. So y equals x plus 1. That looks like a good approximation. And the second one looks like it's going to be something like this, x minus 2. And we have to figure out some way of describing the shaded area between those dotted lines, all this stuff in here. So what I'm going to do is consider those dotted lines, but maybe just consider all the stuff less than the red one. So I want y less than x plus 1. And for this other one, the blue line, I need a little more space here. Let's turn that into y greater than x minus 2. And that should cover all the region which is both below the red line and above the blue line. Okay, so now how do we turn these two equations? I'm going to number these, number 1 and number 2. How do we turn those into a single thing? Well, if you notice what we're looking at over here, all of these inequalities have the x and the y in one spot, on one side of the inequality, the middle side. Whereas the ones we're looking at, the ones we've written here, have them on both sides, the left and the right. So let's try and mix this up a little bit more. Instead of y less than x plus 1, I'm going to rearrange that. I'm going to say negative 1 less than x minus y. Right, see, I just subtracted 1 from each side, subtracted y from each side, and I got this. You might wonder, why did you subtract y from each side instead of just subtracting x from each side? Well, I know I want to get something like these, which is x minus y or x plus y, so I'm going to keep it in that form, make it easier to compare later on. And number 2, this is going to be positive 2 is greater than x minus y. All right, so one way you can combine these together into a mega equation, just a single thing, is I take that x minus y and I say, okay, this has to be greater than negative 1. That's from the first equation. And it has to be less than 2. So I can write it this way. This is equivalent. And if you look at the options here, we see one right up top. This should satisfy what we want.